My name is Varun Dhawan. I'm a principal product manager here at Azure Database for Postgres team at Microsoft. Me and my team, we work on building Azure Database for Postgres Flexible Server, which is our flagship managed server offering. Uh, if you are using Azure Database for Postgres Flexible Server or planning to use it, this will be a great talk, to stick around. So see you there. Hey, hi. So let's get started. So my name is Varun Dhawan, and I'm a principal product manager. Prior to working in this team, I've worked 20 years before in many relational databases, particularly in Target as the DevOps DBA and in McKinsey. I'm based here in Minnesota, the beautiful land of 10,000 lakes, and I enjoy hiking and blogging. And particularly, that's my blog, datanerd.blog.com. You can also find me on my social channels, including LinkedIn, Twitter, and Git. So this is the agenda for today. We will understand, what is Postgres, why it is so relevant in the industry right now, followed by what exactly which we do in Azure Database for Postgres, which is our flagship service. We'll go through the deployments, new features over there. We go through the enterprise readiness features, and eventually discuss a bit of an AI. So let's just dive in. So why Postgres? So Postgres is a large open source database. It's been around for almost 30 years. It's 30 years in development, and it's pretty advanced. From its time, it's extensible. It has got a lot of tooling around it, and enterprise loves it. Whether you are a small organization or large organizations, people have been using it, and it has got a lot of performance and scale. It can scale to any requirement. uh, it has a lot of variety in terms of data types, whether it's text, whether it's search, whether it's geospatial data, and then more recently the vector data. And then this is something which you've consistently seen in most recent year, which is of course becoming more and more popular. Whereby this is from the Stack Overflow survey, where 51% of respondent in favor of Postgres above any other database. So what? So there are two different personas when we build your database with Postgres service here at Microsoft. So one persona is the enterprise, like what is enterprise requirement, and the other being the developers. So let's go through each one of these items and then see what we've added in each of these areas, in last 12 months. So when you get started with Postgres, Azure Database for Postgres Flexible Server, the first thing you have to think about is what is the instance type that you will be using. So usual choices being the burstable, general purpose, and memory optimized. Uh, the burstable is a good choice if you want to get started, with a smaller footprint, and then you want to go, grow as you go. General purpose, if you're running a standard workhorse kind of a workload, it's great. It's 1:4 CPU to memory ratio, and you can scale up to 96 core. Memory optimized, otherwise it's for a larger, more resource intensive requirements. If you want to keep most of your data in cache, if you have a very high IO heavy application, then we suggest using the memory optimized. You can stop these instances. Uh, you can scale these instances, you can scale up, you can scale down, and you can take leverage of reserve capacity pricing to save on the cost. Now, key thing, running a managed service on the cloud is the elasticity, which means you can scale your resources up and down. You can scale your compute, you can scale your memory, you can scale storage, and most of these scalings can be done in online operations. So you really don't need a lot of downtime. Now, storage is critical to any database because you store data, within the database, which eventually sits on some persistent store. And then storage has to be highly performant, to keep up with those, queries that you run or the workload you run. With Azure Database for Postgres, there are two different storage options. There is SSD, which is the previous generation, and then there is SSD V2, which is the new generation. V2 has certain advantages over the old SSD, which is, the larger disk size. It can scale up to 64 terabytes. It supports up to 1,200, megabytes per second is the throughput, and the IO can go up to scale up to 80,000 IOPS. IOPS is very, it's very important for databases if your application is sensitive to latency. The most important thing that we've added recently is the ability to auto grow storage if in case you're running outside the storage. You don't need to pre-provision the storage upfront in demand. And then storage auto grow is available both for V2 and then the older generation SSD. And then we just talked about compute, scaling compute. Now, near zero downtime is also a new capability that we've added, which allows you to basically scale your compute or your storage within 30 seconds. So you can scale your compute and storage together. You can scale them, separately. There's a very small downtime footprint abroad, which can easily be handled if in case your application can use a retry logic. And then eventually, how we handle it under the covers is we basically spin a new VM, and then we scale it with whatever resource sizing you want, and we just swap the VM. So that's how the near zero downtime helps you get the lower downtime. Now we run open source Postgres, and one thing which Postgres community does awesome job is to release one new major version every year. Last year, we released Postgres 17 on September 30th, which is technically just 4 days, after the Postgres 17 release, the community release. Besides the major version, which are released once a year, there's also minor versions which are released every quarter. And in Azure Database for Postgres, these minor versions automatically get applied as part of your, scheduled maintenance, which happens once every few months. Uh, Minor version upgrades, which gets deployed as maintenance, just normally take a very small downtime. For major version upgrade, there is an in-place upgrade option, and you need to plan for the downtime and you need to account for the breaking changes. So we've just talked about scaling of compute. We've talked about scaling of resources, how these can be done online. But there is another important aspect with Postgres, which is the scaling of connections. The Postgres is rather sensitive about connections. So every new connections, take some CPU resources, take some memory resources. A good way to scale your connection footprint is by using a connection pooler, and PG Bouncer is a very popular lightweight connection pooler. The extraordinary job that my team has done is that we've taken this open source connection pooler, we've baked it inside the service, so this comes as a no extra charge to you. And if you want to take advantage, you just go to the server parameter and just enable it. Yeah, I recommend enabling this. And then instead of connecting to the default port 5432, you connect to 6432, and all your application connection goes via PG Bouncer. PG Bouncer will take care of all the idle connections, and it will bounce off the connections if they are not being used, and it will save a lot of precious memory and resources and CPU footprint for you. So you should try. Yeah, you should definitely try this out. Uh, a public cloud provider, is known for for a lot of geo scale. And one thing which we do extraordinarily good is try to make sure that Azure Postgres is available in most of the regions. So as we talk today, I think this is there in already 64 regions. It might be even a little more time, since the slide deck was updated. So you can take advantage of these regions, for your data localization and residency requirements. You can also take advantage of these locations, whereby you want to use paired regions for your geo disasters and geo backups. Now, high availability is very important. Uh, as you decide to run your mission critical workload, your e-com application or your banking or financial application, you just want most of these applications to be highly available. Now, there are scenarios where things cannot be available, some expected or unexpected downtime. High availability is an option to handle that. So when you choose to have your database highly available, at the provisioning time, we automatically create a secondary replica copy for you, whether in the same zone or a cross zone, whatever you choose. And then we build a synchronous replication between these connections where your data, which you commit on primary, automatically also goes to secondary. And in an event where primary, is not available, it goes through an automatic failover. So whenever if there is a issue with specific instance or there is an issue with whole zone, the failover happens automatically. What we very recently introduced is, HA health status monitoring, just to make sure that even when you do not have a requirement to failover, you can always check the failover readiness of your HA instances. Now, backups is the job number one for the DBAs, because data being the most important asset that DBAs manage. We have two different types of the backup. We have physical backups, which is managed via disk snapshots, and the logical backups. Let's talk about the disk backup first. The disk backups come auto provision. So whenever you create an instance, you automatically get backup. These backups are available. You can retain them from 1 day up to 35 days. Default is 7 days. I'll say go with the higher. It's like they save you a lot of pains. And then we also have an option for logical backups, which is basically the PG dump backups, which is your data written to a dump file in a secure location. And then these long-term backups can be retained separately from the database, so can be dealienated. And then you can store them up to 10 years with the help of Azure Vault. So take advantage of these two different backup strategy. So depending upon your application or business case requirement. Yeah. And then finally, we also have geo redundancy, like what happens when the entire regions, is compromised. So for geo redundancy, there's a couple of options starting with the geo backups and the read replica. What you see over here is a classic read replica where you can have up to 5 read replica. The diagram shows two, where East US is your primary region, West US is your replica within the same zone, and then Canada Central is your replica, which is cross zone. So if something happens to East US, you have a choice to fail over to West US or Canada Central. The key difference over here is in case of a read replica, the data replication happen is asynchronous, which is we commit it and it eventually is going to be consistent. Due to this, there is no automatic failover. Instead, it's an on-demand failover. So whenever you think that there is a requirement for you to promote replica, you can promote the replica. You can create up to 5 read replicas, and it's an asynchronous replication. So expect a little bit of a lag, which you can easily monitor using some of the metrics that we published. The key part over here is that uh, besides being a synchronous replication, each server, has a different endpoint. You can fail over, and with the help of site swap, which is a new capability, you can also fail back. So it's really help you, offload your, read. Let's switch gear and talk about security. So there are three things I'm going to talk about, which is intro ID, customer managed keys, and private endpoints. Now, very important thing with the security is you need to know who is logging inside your database and what are they doing. While you have the local stored login, which is your username and password stored within the Postgres, now you also have the ability to use the managed identity or the intra ID logins. Now, intra ID logins are the ones where the passwords is not stored inside the Postgres. Instead, it's managed by your corporate AAD, formerly AAD. Now we call it intra ID. And then user authenticate with the intra ID credentials and all the management and login management that happens at the intra ID. So it takes away a lot of your pain, in managing users and logins and password, at the local level. But you do have a choice if you want to maintain the local Postgres username. Encryption is very important from a compliance purpose. You will just want to make sure that your data is encrypted, even at the rest, at the disk or at the backup level. And this can be easily achieved, by simply checking one single checkbox, which is customer CMK, customer managed keys. Today, we also offer the ability to automatically rotate the keys and make them versionless. So, it's very easy for you to manage the keys for CMK. And then you can store these keys with the help of Azure Key Vault or Manage SSM, which is a hardware security module. So I suggest, it's like there's no performance, hits for doing this. So you should definitely be using this. And then finally, we have private endpoints. I mean to say, hosting your database on a public cloud always makes you think, that now anybody can access my database. It's available on internet. Well, using private endpoint, you can make sure that anybody, only the connections which are originating from your own VPN virtual private network, they are accessible. They just go inside the database. With using this, you can prevent basically the data exploration and make sure that there are no leakages, and the private endpoints is directly mapped, to your specific database resources. What else is that you can even go further and configure more fine-grained access control with the network security groups or NSG. So private endpoint is like makes your defense more secure. Yeah. Now we talked about many things, including the backups, replica, security. One thing that DBAs loves and sysadmin loves is once you've everything configured, you just want to monitor all this, and you want to monitor it at a larger fleet level or a scale level. The monitoring in Azure Postgres is achieved with multiple ways using metrics and logs. We use a central service, which is Azure Monitor, which continuously aggregates your metrics and logs. And then once these metrics and logs are aggregated, you can do multiple things. So you can derive insights using multiple monitoring solutions and query performance insights. You can easily chart and visualize this data using your favorite tools like Grafana, Workbooks, Power BI. You can respond to them by setting up alerts or using the service health. And you can analyze this for a long term predictive model using writing powerful KQL queries or using the Matrix Explorer. Uh, we want to bring in some autonomous capabilities beside the reactive monitoring. And one of the autonomous capabilities that we've recently introduced is the index recommendation. Index are building blocks of performance. Uh, and then one feature that we introduce is the index recommendations, whereby once we enable the index recommendation, again, just a checkbox, we automatically start analyzing your workload, and based upon your workload analysis, we start suggesting you a couple of things regarding your indexing strategy. So, A, are you missing any index? Like by creating an index, can your workload run faster, your queries run faster? And then number two is, do you have a lot of redundant or duplicate indexes, which is just every time your auto vacuum is running or every time you're inserting your database, it's an extra overhead of updating, these duplicate data structures, and you can get away from these indexes. So once you enable this, you automatically get these recommendations and you can, choose to follow these recommendations. And then what you see on the right hand side is, some of the, some very high level analysis for our customers, who have enabled index recommendations, and they have seen drastic improvement their query execution time, both for select, inserts, updates, and deletes. It's almost half, after enabling the automatic index, recommendations. Postgres, is a really extensible. It's really special as a database. You can extend the capability of Postgres in many different ways. There are thousands of extensions in Azure Database for Postgres. We support like almost 70 plus of those extensions, the key ones, including timescale, Postgres, PG audit, more recently PGVECTOR. It's very easy to enable an extension. You can do it with a CLI command. You can do it with a portal. You can do it with an API or Terraform. What recently we have introduced is the ability to upgrade the extension version. So you don't have to basically go to a different version of Postgres only to have a new extension version. You can just do it staying within the same version. And so the new extension at the time of writing this deck were the Anon and Oracle FDW. Then we have the ability to do the major version upgrades. Major version upgrades, Postgres community release one major version, every year. They've been very consistent for past many years. And every major version comes with, a lot of improvements, a lot of performance improvements. Uh, and we want our customers to always be taking advantage of these major versions. While you can use more conventional tools like a PT dump and restore, but one of the most native and easy way of using a new major version is running the major version upgrade, which is just one single click upgrade, feature. You do not require to migrate the data. You do not require to set up a separate server with a separate cost. There is some downtime, but fact that everything is an automated in a major, in the MVU experience that we built in, that downtime is minimal. You can do the MVUs with both portal and CLI. And there is a lot of observability logging which is available for major version upgrades. So just in case you run into some pre-upgrade issues, we generate a log. We tell you what are the reasons by which your upgrades are not compatible. The reason why you cannot go from 15 to 16, for example. You can read the logs, take care of those issues, and then retry the upgrade. So I say, definitely, whenever it's possible, try to stay latest, be running on the more latest version. Now, elastic clusters is a new feature that we've introduced, last year. Everybody loves, this the awesome extension Citus, which helps you scale your database horizontally. Otherwise, the relational database are basically known to scale, vertically. With Citus extension, you can shard your database, and you can shard based upon this row-based sharding, the schema-based sharding, or maybe shard at the database level. With Citus extension baked inside the Azure Postgres for Flexible Server, which we call the Elastic Clusters, now you have almost the infinite scalability, and you have a very simple sharding mechanism where you do not have to, spend a lot of time re-architecting or rewriting your applications. You can promote, your database, from standalone to a Postgres cluster. So if you're today running, a single standalone, flexible server instance, you can actually convert this into a Postgres Elastic cluster, and it has 100% compatibility with Postgres. All the goodness of Citus extension. From an AI perspective, I want to talk about a couple of things. So one, definitely, PGVector, gets supported out of the box because thanks to the goodness of PGVector extension. Now, using PGVectors, one thing we realized is that it was quite a challenge, for DBAs to integrate the PG vector, extension, and then talk to LLMs, for all the AI requests, which is why we also built an Azure AI extension. So combined with PG Vector and Azure AI, you can actually vectorize the data, and then you can integrate it with any large language model such as an OpenAI, and then easily run your AI type of workloads. The thing that I'm specifically calling out in this slide is the DISKANN. So every data type needs its own specific indexing. Initially, we had HNSW and IVF flag. However, Microsoft Research, have worked on a new index type which works, beautifully with the vector, which is DISKANN. And we have implemented this KN, and it's available as an extension in Azure Database for Postgres Flexible Server. So it makes a vector queries run faster, and it makes a vector queries runs really accurate. So this is also a new feature that has came along in last few months. So if you're planning to use vectors, and if you're planning to use Azure AI extension within Azure Database for Postgres Flexible Server, give DISKANN and try. Compare it with HNSW and IVF flat, and you will see the performance improvement that we achieved from quantization, the compressions and the SSDs. Finally, a lot of things that I've talked about, we almost, we have a good release velocity. We release a lot of these features, every month. And one thing that our team does a lot is blog about these features. So this is our blog. You can follow our blog over here, which is Azure Postgres blog, and then you will keep seeing all the new features. We'll keep talking about all these new features over here. Yeah. And then this is bunch of resources. Some of the important ones, like I will really recommend to get started, with a free account. If you haven't tried, if you're already using Postgres, then obviously our blogs and talks is something that team invests a lot of time in making sure that these are updated with month on month every time we release a new feature or we release a new improvement. There's a lot that team does, on LinkedIn, and other social platforms. You can ask questions over the channel and reaching out to us over the email. Yeah, with that, we've come to an end. Thanks for being around. Now, while I'm over here in the conference, I'm also taking questions on Discord. So just in case there is anything uh, that you had in question which I presented, or anything which I never presented, and you still want to ask about Azure Database for Postgres Flexible Server, I'm hanging on in Discord. So definitely shoot your question over there. If in case you also want to hit me up, on LinkedIn, please feel free to do that. So again, thanks for spending time with me and listening to all the new features that we have released for Azure Database for Postgres Flexible Server in last 12 months. Hope you find them useful and enjoy your conference. Thank you.